All right, time to talk about WeCloudData's data engineering program. I'm assuming that's what you're here for. I think this is one of the very few data engineering programs out there. The reasons why you don't find a lot of data engineering programs offerings is because data engineering is very hard to teach. It's a lot harder than data science because data science has theory. You need to teach machine learning, statistics, right? Decision trees, regression, pretty standard. Lots of great content online as well. Because the fundamental principles don't really change. You can use TensorFlow like the best tool, but decision tree is still just decision tree. It never changes, right? Unless you have new algorithms coming out. But companies don't really switch algorithm on a daily basis, right? So data scientists will do a lot of experiments in the lab, but when deploy some algorithms, sometimes for performance, concerns, they may still just use regression models. So I think data science is relatively easier to teach. It doesn't mean data science is easy to learn, and it doesn't mean it's easy to become a great data scientist, right? The reason why we don't see a lot of data engineering programs out there is because, first of all, I think universities, I've looked at some of the university programs that's a little bit like, it's not a data engineering program, it's some kind of close to, data engineering. The things they teach are very outdated, right? Hadoop, and even Apache Pig in the curriculum, but Apache Pig, no one uses it anymore. And it's kind of hard for a university program to keep up because, for a program to get approved, you need to go through very rigorous, curriculum design and approval. The whole process can take like months and, 3 to 6 months, for example. And that's why and once they design something, they're not going to change that very frequently. So I don't think you can learn data engineering, like the modern data engineering skills, very well, like from universities and colleges. And boot camps, I think there are a ton of coding boot camps out there. Maybe because data engineering is relatively new, I'm pretty sure there will be more in the future. But finding data engineering instructors are very challenging. People who have the experience, they work for Google, Twitter, they get paid a ton. So how much time do they have to design a curriculum and then be able to teach well? That's also very hard. But anyways, WeCloudData, is fortunate to have like really strong, faculty, team. And also we've been running this program since February last year, and the learning outcome is awesome. So scan a barcode. You can, have this link as well. One, you can share the link with you guys. Go to the website and you'll be able to find all the details. Just let me share my browser. So this is the data engineering program page. You should be able to download the actual syllabus that has all the details you need. So just click on view full syllabus, and you can download syllabus if you're interested. Someone on our team will reach out, and you still need to go through an admission process. So you need to do a Python SQL test, and before you get approved into the program. There's some videos, events from the past that you can check out, and there's some sample projects with diagrams created by our students. I'm going to share some recorded videos with you today, so you can try to understand what the students are able to achieve in a matter of 6 months. Okay. This program is for mainly for career switchers and new grads, so people who want to become a data engineer. If you already work as a software engineer, then I would say there's the Google. I think Google. There's a GCP data engineering certification program either on Udacity or on Udemy. I forgot. If you're very strong in software engineering already, I think you have the right learning aptitude and also the skills to just pick up things really quickly. It shouldn't be that hard for you to switch to data engineering. And of course, you need to accumulate experience when you actually get hired as a data engineer. So you can consider our program, which is part-time, but you can totally just learn that on your own. But if you're a software engineer who's not very familiar with data, you're absolutely going to benefit a lot from this program. But this program was created mainly for career switchers, right? So people who are not coming from data engineering and software engineering background. If you are an ETL developer, DBA, so if you work with SQL data already, but more on the traditional tech stack side, you would like to learn, open source, Spark, Docker, DBT and Airflow. This is a great program for you if you'd like to make the switch. Or if you're just IT professional in general, like working on QA, you would like to switch, this is the program that can help you make successful switch as well. A lot of those students will be in the full-time program, so they can leverage the real company projects, so they can add those experience to the resume. And most importantly, experience what the real project looks like and also contribute to the project so that they can build up their skills and experience quickly. For recent graduates from engineering, discipline, you can, this is the right program for you as well. We also worked with students who are newcomers, who are landed immigrants, who already have, data experience, but they don't really have local education experience or don't have local work experience. This is a program that can help you. We also have quite a few data scientists in each cohort who would like to become data engineer because they sort of feel like data engineering is booming, and they they would like to upskill themselves. And there are some of them who actually wanted to become data engineers because they sort of get bored of tired of machine learning, I guess. All right. Let me tell you how WeCloudData's data program is different. So first of all, on the training side, you have many options, right? As a learner, MOOCs, college programs, traditional boot camps. WeCloudData is a boot camp as well. MOOCs in college are great for self-learning, but to get to a point where you are actually competitive enough to get into the industry, I think building portfolio project is really important. Like whether you're coming from computer science or from some other background, if you want to become a data engineer or data scientist, you'll definitely have some sort of project experience. And the main reason is because unlike doing LeetCode, right? Because if you want to get hired as a software engineer, you need to have great, background and you need to just pass LeetCode. And because LeetCode is pretty hard and you have to learn data structures and algorithms, system design, all of those are great. And it's sort of like a standard nowadays, but for data professionals, someone who's good at LeetCode, it really doesn't mean they can do data well. Working with data is very different. And that's why a lot of companies prefer to give take-home assignments. They would like to take a look at your portfolio to see what you can actually do. And a lot of boot camps help students build portfolio, which is great. But it's not enough, right? Because there are a ton of open source projects out there that you can find on Kaggle, and a lot of great projects on GitHub as well. It's still kind of noisy and hard for the hiring managers to tell, like whether you can get the job done, right? So, and that's why some companies will give you a real data set, right? A anonymized data set, and ask you to build a pipeline. We've seen companies asking candidates to write Spark jobs based on some kind of CSV files, and they have to package everything up and deploy that in containers. And there are companies that require candidates to actually launch like a Redshift, whatever database in AWS cloud. They have to do all the data cleaning and write unit tests and stuff like that. So they want to make sure that you can actually analyze data and build pipelines. Most of the boot camps will have career advisors, which is a great service. I think it's much better than the career advice, whatever career service you're going to get from a university. And these are typically one-to-one support. But I found that like many boot camps, because of the cost, these career advisors are not really experienced in data engineering, especially it's kind of new. So, someone who knows data engineering, they're much less likely to just work as a full-time career advisor to help students with resumes. And that's why WeCloudData adopts a little bit different model. We have everything that MOOCs and traditional boot camps have. We help students build 2 very strong portfolio projects. I'm going to show you the demo. And we have industry mentors. So you work with someone who work as a data engineer in the field to give you guidance. And most importantly, for students who are full-time or part-time students who would like to get project experience after graduation, we have this opportunity for you to shape up your skills and experience. Let's talk about the curriculum. And the program is divided into different modules. I don't think this is the most up-to-date version because our program manager Eric keeps updating them. Like every cohort, we have discussion and we update the curriculum based on the industry demand and also the feedback from the students. But this is the overall curriculum. It could be pretty overwhelming, especially for someone who's new to programming. So that's why we have some kind of admission test. If you don't even know SQL and Python, you can still become a data engineer, but you need to set the right expectation. You're not going to become a data engineer in 3 months, right? It's going to take a lot of effort. But if this is what you want to do, WeCloudData can definitely help you. You can join a pre-boot camp to learn SQL and Python. And in the boot camp, there will be a lot of practice. But we don't teach you SQL and Python from scratch because this is a pretty loaded program and that teach you a lot of the modern tools. But trust me, there are students who are frustrated, from the beginning to the end. And there are students who complain saying that, it's too intensive. That's why we keep improving the program. There's no excuse on our part. But the moment the student got the job, they really appreciated it. So I'll show you one project demo done by a student who had no programming experience before joining the program. That was when the pre-bootcamp material wasn't great enough and he really frustrated, but he worked on the real project. He interviewed for 2 companies, got 2 offers, and he was pretty satisfied. But he put in a lot of effort, and we could tell how hard he works, even though he complains. But we got a ton of great suggestions from the students, and that helps us improve the program as well. Anyways, back to the curriculum. We start from programming. We will cover Linux and Docker. This is part of the pre-bootcamp as well, but we actually do lectures on Linux because we feel like it's actually very important. In SQL, Python, we will cover more SQL starting the new cohorts, but we assume that students know Python or who can spend time in the pre-bootcamp to learn Python. But I think Eric also decided to add more Python, more advanced Python topics in the bootcamp. And Scala, we used to cover Scala. Scala is optional. You have access to auto-recorded videos. And so which means we made a decision to focus more on the PySpark side instead of Scala Spark. And the main reason is because if you look at the landscape, PySpark is actually more popular than Scala Spark right now, and also Snowflake, which is, I guess, the most successful or popular modern data warehousing, startup. Well, it's not a startup anymore, a company. They recently also announced the support for Python and the UDFs. It's all Python, right? You can still get a lot of performance boost if you use Scala, and serious data engineering teams will still require Scala and Java. But I think, from a program organization perspective, teaching Python is going to be the most effective way to train students to become data engineers. And we do provide the resource needed for the program. So it's optional for the new cohorts. And after that, we introduce students to cloud computing. We primarily focus on AWS Web Services. We touch on quite a few services, and students will be launching databases, data warehouse, working with Athena, EC2, S3, but basically compute, storage, databases, and also big data, right? Working with EMR and also Glue to build data pipelines, serverless. We introduce Lambda functions as well. And we used to offer GCP, but now the focus is more on the AWS side. It's primarily because we are more experienced in AWS, and also AWS is the most popular cloud along with Azure. So the demand on AWS side is definitely higher, but a lot of people suggest us to offer GCP because they start to see more companies using it. So that's why we used to teach both, but then we realized that, it's not the best use of students' time. We want the student just to get good at one of these tools. And then if you know AWS, it's not that hard for you to pick up Google Cloud, but everyone will have recordings to the past, GCP classes and labs. So you're not missing out on any of the content. Okay. From time to time, depending on the which programs you're in, like if you work on the real company projects, you might be working a lot with Synapse and Azure Data Factory if you work on the projects. But in the program, we focus more on AWS. Okay. And after that, we introduce, data warehouse and big data. This is not the right sequence, but on the big data side, we touch on MapReduce and Hadoop, but it's not the most popular big data tools anymore. The entire landscape has, again, evolved and changed. I think Hadoop, Hive, and MapReduce have been really popular, right? Especially for the big tech companies in the last 10, 15 years. But things are changing again, right? Modern data stack. If you Google modern data stack, right, you'll find data warehouse tools such as Snowflake, dbt, ELT instead of ETL. But again, there are less and less companies using Hadoop. So it sort of becomes, legacy systems, or the data you're dealing with is at the Uber scale or Facebook scale, then they're still going to be storing data in Hadoop, but there are many other options nowadays. We definitely have a big focus on Apache Spark. In both capstone projects, students will be working with Apache Spark. Midterm, I believe it's, just PySpark data frames, do data pipelining. But term 2, capstone project students will be working with Spark Streaming for real-time streaming data analysis and Delta Lake or Lakehouse. And on the data warehouse side, in this upcoming new cohort, we've decided to increase the weight on data warehousing. It's just such a popular topic. Data warehouse has been around many, many years, right? It used to be dominated by companies like Oracle, Teradata, all the companies I used to work with, the big tech companies, they all have data warehouses. But we're talking about the modern data warehouse now, which means it's not the traditional ETL workflow, it's more like ELT. And we'll be focusing more on data modeling and how data warehouse actually work. So we're pretty excited about the data warehousing piece. If you have data warehousing experience with Snowflake and dbt, I'm pretty sure you can get jobs easily. And then, of course, when it comes to data engineering, you'll definitely need to know, the general data processing and data transformation, right? Which is ELT, ETL. So we'll explain the differences, between ETL, which is short for extract, transform, and load, and ELT. Oh, sorry, I have ETL and ETL. It's a typo. It should be ETL and ELT. But again, we'll be introducing some new exciting tools such as Airbyte for data, for data ingestion, Apache Nifi. For integration, of course, you use Apache Spark and using dbt for data transformation. But again, you need to write SQL, right? And when the company has real-time data, we do stream data processing as well. So that's what we teach at the end of term 1 and at the beginning of term 2. In term 2, the focus will be on the data lakehouse side, which is something I'm personally very excited about. So in the world of data engineering right now, there are 2 different kind of schools of, thoughts, right? Different philosophies. Should we build a lakehouse or data warehouse? And we're talking about the modern data warehouse because, tools like platforms such as Snowflake is already very powerful, and it can even do like machine learning nowadays. But we feel like Lakehouse is really promising, and so many companies are starting to build Lakehouse. So that's why we cover both warehouse and Lakehouse. And the reason why data Lakehouse is getting more promising is because data lake sort of failed on its promise, right? And companies, not only own big data, they also do a lot of the transactions. They want data, analysis to happen quicker, right? So sometimes they have streaming data as well. So this requires, setting up the right infrastructure to do that. And traditionally, companies are just dumping all of their big data into Amazon S3 or blob storage, Azure, data lake, and then hoping magic could happen. And then Apache Spark, Hadoop, all of these tools can help them build pipelines. But what about the real-time use cases? What about change data capture? What about the GDPR or the California whatever Data Privacy Act policy, right? So that requires companies to be able to delete data, private user data upon request, and it turns out to be pretty challenging. But with Lakehouse, it's actually becoming a lot easier. So there are some exciting projects out there, such as Apache Hudi, Databricks Delta Lake, which is partially open source, and also Apache Iceberg. Some people are more excited about Iceberg, which is open source at Netflix. Some people are more on the Hudi side. I think there are more users on the Hudi side, but again, we focus on Hudi and Delta Lake, a little bit Delta Lake, I think, because it's not purely open source, but pretty exciting piece. We've been teaching that since the very first cohort, but I think the curriculum is getting better and better. So I'll show you some of the demos. We cannot talk about data engineering without mentioning data pipelining, right? Orchestration. As I said, companies building 5,000, 10,000 data pipelines. There's no way you can manually run all of these. So you need some kind of workflow orchestration tool. Apache Airflow is one of the best tools out there. There are also new ones coming out. But if you want to build a general data pipeline that touches on many different kind of, different cloud, different pipelines, different tools, Airflow is still one of the best tools. If you want to run data warehouse and the workflow purely in data warehouse, dbt is one of the best tools out there right now. So many companies are pushing for it. We're pretty excited about it as well. So I'll be covering both. And of course, the DevOps side of things, CI/CD. You're not going to become a DevOps engineer by completing the CI/CD module in this course, but it teaches you enough on CI/CD basics, Docker, and we do cover Kubernetes, and pretty extensively. But again, it's not the right course for training DevOps person because we're the users of the platform. Okay. In the data quality section, we're also planning to add unit testing and how to build basically better practices around continuous integration. We cover data governance as well. It's not a huge topic, even though data governance is such a massive topic, but it's not a very big part of the program. The program is still very technical, and data governance is all about the right people, policy, and process and technology, right? But we do want to focus on data quality, how to do data cleaning, right? Different kind of data. Data cataloging is sort of covered in the project part because we will be working with some of the data cataloging tools, metadata management. So I think this is a very practical program, so we're not going to cover a lot of theory. So we'll teach you how to work with those tools. On the data privacy side, how to mask data, hash data, encrypt data, and these will be covered in a new program as well. And of course, project management. How does data engineering project work? I think we'll cover some of these through guest lectures. Each program we have AMA sessions, so you'll be learning from the instructors, like how their take and views on the job market and how to prepare for a data engineering career. But we also have invited guest speakers who can teach you very specific topics, and the speakers will change from cohort to cohort. Okay, so this is an overview of the program curriculum, and Now, I would like to show you some examples. So I sort of talked about, the portfolio projects and the importance of it. Let's say we have a candidate A who has, decent education background, who has the programming skills and also worked on personal projects. And WeCloudData's data engineering graduates, they not only have the right technical skills, but they also build portfolio projects. That's the two capstone projects I mentioned. So check out some of these links. So WeCloud DE project demo one. Let me click on it and open. Sorry, why is the link not working? Give me 1 second. Let me just copy this directly and share that with you. Go check it out. So this is a presentation done by Peter.
Morning, everybody.
Who recently got 2 offers. He's in the full-time program, so he sort of worked on real projects. He's from travel management experience background, so we were really happy for him. He didn't know any programming, but what he was able to produce is very, very promising, and we're so happy to see the outcome. I guess I will not turn on the, maybe I'll just quickly show you what he did, but you can check out the video yourself. So he worked with the Toronto TTC data. So there's a Toronto TTC, whatever, bus, like data API. So he's streaming those data through Apache Nifi. So he set up the data ingestion on the EC2 instance in AWS. And it's a Nifi, which is the data connectors ingesting data into MySQL database, and he set up change data capture using WZM, and that ingested data into a Kafka cluster. He's using the MSK, so managed Kafka cluster by AWS, and data coming through Kafka, and then he's using Spark streaming to analyze the data, and this is where the change data capture happens with Apache Hudi. So he's this is the Lakehouse architecture, by the way. So he's using Spark streaming to ingest the data into Apache Hudi, which writes data to a Parquet file, which is saved in Amazon S3. And he's using an open source visualization tool called Superset. A lot of companies use it to do the visualization. So everything is set up in AWS, and he's actually able to visualize, do some pretty cool map visualization in real time. Let me see if I can find it, but this is the data architecture. This is how he set up the Nifi connectors.
Through the Spark is happening as
and he was just demoing how he did the real-time data ingestion.
so basically,
1 second.
So
yeah, so this is real-time dashboard he built. He's actually streaming the TTC data, and it's actually showing like the movement of those buses in real time, which is pretty cool. It's not really big data, but the entire data pipeline he built is pretty state of the art from a data lakehouse architecture perspective. Let's take a look at another project done by a student, Sammy. So Sammy, as I said, he didn't have any experience, and he loves gaming. So he tried to find a game API, and it's pretty cool. He was trying. Let me see if we can find the. And this is the end-to-end data pipelines that Sammy built. Can't find it, but it's actually in the slide. 1 second. Yeah, so this is the architecture or the pipeline built by Sammy. He actually had to learn a little bit C# in order to get the API working. So kudos to him. And he's using Python Fast API to read the the data and ingest the data into Apache Nifi. So I think he's working with the webhook. And then again, setting up the CDC using Kafka and Spark streaming. So the instructor will, this is a very complicated project, and instructor will it would take the instructor actually, I think 15 hours to just to go through the whole thing. So there will be a template, and the student will need to come up with their own ideas to figure out what data source they want to work with, and a lot of students will make changes to the to the data pipeline to make it work. So that's what you would expect, but definitely this is a project that requires the students to be able to setting everything up, the infrastructure on Amazon Web Services, writing some Python scripts to collect data, do data ingestion, set up, writing Spark scripts to analyze the data, and also, visualizing the data at the end. So hopefully you find this useful, and go check out the videos, and you can find some other details on WeCloudData's website as well. Okay. All right. Now, I would like to introduce the real company projects. This is for full-time students who who can study like Monday to Friday. The learning schedule will be the same. It's weekday evening and a Saturday, but the full-time students will be working directly with our clients and also our project team on real projects. And you might be assigned to very different projects, but there are lots of data engineering projects that you can work on. With the real projects, I think you're able to add real experience to the resume, so you won't look very junior. And those are real experience, managed by project managers, and you're working directly with the client. And all of these projects seriously will need to be delivered at its best quality. So students are going to learn a lot on these projects. There will be pressure to deliver things, but that's the best way to train students in a short amount of time to make sure that they're job ready, right? No amount of, self-learning can match this, I would say, but the cost is also very high. I'm talking about the time cost. So it takes a lot of effort, but if you're serious about jobs, career switch, this will be one of the best ways. I'll tell you one of the give you one of the examples. I can't share details, but this is one of the data warehouse project I previously mentioned. I think the real value, or the value of a real projects, is that you're going to learn not just the coding part, right? So in the program, you're going to learn data warehousing, data ingestion, data lake. You're going to learn all of these technology, these techniques, but it doesn't mean you know how to build a data warehouse in real life. And sometimes the project team is also doesn't have all answers to all the questions coming from the students. There will be debate as well, and people will have their own research done, and they will think that one approach is better. There will be disagreements, but that's how real life works, right? And you're going to learn a ton through that process. So this, in the program, you're going to learn all of these, right, cool technologies, but how to put all of these together, I think the two portfolio project can already give you a huge advantage. But if you don't really come from, right, coding, software background, or data background, the switch will still be a bit challenging, because looking at your resume, that's like you need a strong resume even in order to get noticed, right, by the employers. So how do we solve that? Build real experience, right? And if you look at the purple boxes here, these are the things that students will learn on real projects. For example, understanding the business needs, doing data profiling, right? Coming up with the plan, how to manage clients' expectations, how to do the UAT properly. So all of these are the things that are very hard to be, to train in a class setting, because I don't think anyone will be interested in this kind of course. It's also very hard to design, but by working on a real project, that's what you're going to learn. If you look at the blue boxes here, system design, documentation, even doing research on the best tools to use, right? So we decided to use Airbyte, which is not part of the curriculum, but we think that's one of the best tools to consider for this project. We didn't end up using it, actually. did a ton of research, and and then WeCloudData itself decided to adopt Airbyte, which is really cool. But I think students will look at a data project from a different angle. Like, how do we choose the right tool? A lot of the small decision making and is actually what a data engineer wanted to do in real life, right? And understanding building the overarching data architecture for the entire data pipeline before someone actually implements it. And even how to do documentation properly. And I found that a lot of students don't really understand how to do documentation properly. And that is actually a very important skill to have for any kind of data professionals. Okay, so that's the real project. And also, in terms of the curriculum, we sort of stick to some of the best, best practices. And this is a reference architecture created by WeCloudData. And of course, we learn a ton from, other resources in Amazon itself. So we'll be covering some of these. This is not the Lakehouse architecture. We have a different one for Lakehouse, but just so they will be learning the most cutting edge, technologies. Yeah, again, I think that's the end of my presentation. I sort of shared the student learning experience already. So just to reiterate, you need to go through an admission process, do the quizzes, and then the program manager will have a quick chat with you, try to decide if this is the right program for you. We don't want you to join a program and regret. So sometimes after talking to the student, they realize that, oh, maybe data science is a better fit, or BI program is a better fit, right? And after that, you will join a pre-boot camp preparation. After the pre-boot camp, you pick up Python SQL skills, and then you join the boot camp. Boot camp is 6 months. Full-time student will work on projects. And for part-time students who have a full-time job, so if you cannot commit to real projects, some students actually will go through the program first, graduate after 6 months, and then they will choose to join the client projects to learn how to work on real projects and build up their experience. So there's an option if you would like to do that later on. Okay, every student, regardless of the program or whatever option you go with, you will always get the career mentorship. It's just part of the the program you're paying for. So there's no additional fees you need to pay.